Hello students, welcome to lesson number 8 on circle theorem. The last time we met we looked at lesson number 7 where we looked at theorem 6. There we saw that in a cyclic quadrilateral the angle between the extension of a chord and an existing chord is the same as the interior opposite angle. That is, the exterior angle of a cyclic quadrilateral is the same as the interior opposite angle. Good. So I gave you an assignment and we will start today's lesson with solution to the assignment. I hope you all did the assignment. Good. So now let's look at the assignment. In the diagram below, O is the center of the circle and ABCD is a cyclic quadrilateral. Angle EAD equals 115 degrees. Find IX, IIY, IIIZ. Good. So I told you that always there are clues in the question you have to look out for. So in our question, it said that ABCD is a cyclic quadrilateral. So this should tell you that you have to apply a theorem concerning cyclic quadrilateral in getting answers to some of the questions. Okay, so you have to apply a theorem concerning cyclic quadrilateral. Good. So our first question was to find X. Now looking at our diagram, it's a cyclic quadrilateral where there's an extension of the chord AB. Okay, so this chord AB has been extended. And this extension and this already existing chord, there's an angle between them. Okay, so this angle was given in the question, that is angle EAD. The question gave that angle to be 115 degrees. So this exterior angle here is 115 degrees. And per the theorem that we learned, this exterior angle is the same as the interior opposite angle, which is this one. So it means that to find X, we just have to equate this angle to X. I hope you get it. Good. So that will be the solution to the first one. And the second one, we have to find Y. Now looking at the diagram again, it's a cyclic quadrilateral. And this 2Y is an angle opposite to this 120 degrees in a cyclic quadrilateral. So we said that in a cyclic quadrilateral, opposite angles are supplementary, meaning they add up to 180 degrees. So it means that 2y plus 120 degrees should be equal to 180 degrees. And when we make y the subject, we'll be able to get the answer for what? Y. Okay. Then finally, we have to look for z. So with z, the same way, looking at it, you can use either opposite angles of a cyclic quadrilateral or angles on a straight line. Okay, so using opposite angles of a cyclic quadrilateral, the z and the x are opposite angles. Okay, so it means that when we add them together, it should be equal to what? 180 degrees. The same way, when we looking at this line is a straight line. And we know from plane geometry 1 that angles on a straight line add up to 180 degrees. So it means that the z plus the angle here should be equal to 180 degrees. And when we make z the subject from the equation, we'll be able to get the answer for z. Good. So I hope you are with me on how to get the answers. Good. So now let's present our solutions. Let's present our solution. So always write the question number. So question number 1, I. So with the eye, angle BCD is equal to angle EAD. So let's check this statement or equation. Good. So angle BCD, that is this x, is equal to angle EAD. Okay. Good. So substituting, we have angle BCD is our x, and then angle EAD was given as 115 degrees. So this is the answer to the I. Now let's move on to II. Now with the II also, we have angle ADC plus angle ABC equals 180 degrees. Okay, so let's check that one also. So angle ADC plus angle ABC should be equal to what? 180 degrees. So let's substitute. So our angle ADC is the 2y plus angle ABC is 120 degrees. So this is equal to 180 degrees. So solving for 2y, we'll have 2y equals 180 degrees minus 120 degrees. So our 2y will be equal to 180 minus 120 is 60 degrees. So y is equal to 60 degrees over 2. So our y is what? 30 degrees. Okay, so the last one, that is III. With III also, angle BAD plus angle EAD should be equal to 180 degrees. Okay, so substituting, the angle BAD is Z plus 115 degrees equals 180 degrees. So our Z is equal to 180 degrees minus 115 degrees. So our Z now will be equal to 180 minus 115 is 65 degrees. Okay, so students, these are the solutions to the assignment. So cross-check with yours, and where you didn't get it, make sure you go over it and you get it. Okay, good. Now let's look at the main lesson for today. The main lesson for today. So we are now on Theorem 7. Theorem 7. So let's look at Theorem 7. Good. Theorem 7. Now, the diagram I have here, okay, it's a circle with this line and this line. Now, what is the name of this line? Okay, if you said radius, you are right, because we defined radius earlier on, that any line from the center of the circle to the circumference is a radius. So this line is a radius. Now, what's the name of this line? Good. If you said tangent, you are right. So this line is a tangent to this circle. because it touches the circumference of the circle at only one point. Okay, so this is a tangent. So the theorem 7 is between radius of a circle and tangent to a circle. Now the theorem says that anytime radius of a circle meets a tangent of a circle, the angle formed between them is 90 degrees. So the angle between radius of a circle and a tangent is always 90 degrees. So it means that the angle here is 90, the angle here is also 90. Okay, so this is radius, this is a tangent, this is radius, this is a tangent. So the angle between the radius and the tangent is always 90 degrees. So in other words, we say that radius of a line is what? Perpendicular to what? Tangent of a line. So anytime two lines are perpendicular, then it means that the angle between them is 90 degrees. So this angle, this line is perpendicular to this line. And for that matter, the angle between them should be what? 90 degrees. So I hope you get it. Good. So the tangent can be anywhere. It can be this point. Okay, we can have a line. Sorry. So we can have a line touching this point. So if we draw this, okay, it means that this angle here is 90. This is also at 90. Wherever the tangent will be. My hand is not straight. Okay, so we have this line. If we draw a line from here, this is a radius. So the angle here is 90, the one here is 90. Okay, so student, this is how far time will allow us for today. Make sure you revise and then you read ahead. The next time we meet, we'll be looking at theorem number 8, and probably we'll end the lessons on all the theorems, hopefully on lesson number 9. Okay, so see you again next time. Bye.